In this example, we'll be applying the method of joints for truss analysis. As you can recall from class, the method of joints is very useful when you want to solve for all forces and all members, which is what we have in this example. Here we have a truss with 9 members, and you can see that my forces here, the 6K and the 6K, these are external loads. Over here at point A, I actually had a pin which had a reaction of 10K to the left horizontally, it had a vertical reaction of 6K upward, and then I had a roller over here which had a reaction of 16 kips. Okay, so in this example, as I mentioned, I've already solved for the reactions. Those are at A and B. I have 2 loads of 6 kips at point E. And as I mentioned earlier, we're going to solve for all forces and all members. So with the method of joint, essentially you're going to start and you're going to work joint by joint, and then the information you collect from one joint you're passing to the next. I'm going to start at joint A. I try to start at a point where I only have a couple of unknowns. Okay. So when I look at joint A, of course, I've got a force of 10 kips that was given to me as a reaction. I've got this force here of 6 kips going up. Okay, those are my reactions. Okay. And here's the joint itself, so I'll pick joint A. Alright. And actually, let me simplify this a little bit here. I'll move this over a second. So at joint A, I'm going to show force here, and I'm going to put my reaction just to the left of that, so I have room, so it's clear which one's the reaction and which one's the force. Okay. So again, at joint A, I've got a reaction of 10K going to the left. I've got a reaction of 6K going upward. Okay. And what I want to do is I want to solve for my force in FAC, and I want to solve for my force in AB. Okay. Now, looking at this from a horizontal perspective, I can see that this force AC is going to be going to the right, or it's going to be in tension, since the only other horizontal force I have is going to the left. Likewise, from a vertical perspective, if I have a force of 6K going up, I know that this force has to come down. Okay. So now that I've drawn the joint and I've drawn my known forces and the forces that I'm solving for, let's just go ahead and apply the equilibrium conditions. So in the x direction, of course, they have to equal 0. And I've got minus 10K, that's going to the left, plus the force in member AC has to equal 0. So FAC is 10 kips, and it's in tension as I had shown. Okay. I could have guessed that FAC wasn't going to the right. I could have guessed it was going to the left in compression, and my equation would have come out negative, indicating that my assumption was incorrect. I'm going to do the same thing in the vertical direction. Okay. So in the vertical direction, I've got 6 kips going up, which is positive. Okay. And then I have FAB going down. Okay. So when I solve for FAB, I get 6 kips, and this is also in tension. Okay. So I kind of went after the low-hanging fruit first, and I looked at a point where I have 2 unknowns, and so I went ahead and solved for this member here and this member, AC and AB. All right. I'm going to go ahead now that I know AB, I'm just going to work my way to the next joint, which is joint B. And the process is going to be identical to what I did for joint A. So at B, I've got this vertical member here. I know this known force, this reaction that we have is 16 kips going to the right at B. Okay. I also have a force here. Okay. Now, we found that AB is 6 kips in tension. Okay, so these are all, in a truss you have 2-member forces, okay, 2 force members. So they're either all in tension or they're all in compression. Okay, so we calculated earlier that FAB was 6 kips in tension. Okay, so I'm going to draw, and this was FAB, and this was 6 kips. You can see it's in tension. I need to move this over so I can draw in my other member real quickly. Okay, so I have 6 kips in tension. That was what we found for AB. Okay, I don't know what the force is going to be in member BD. I'm going to go ahead and guess it is going to the left. Okay, and I'm just going to label this as force BD. And of course I have another force going on in here. Okay. I know the direction of this. I can see that visually, I can see it's going to be in compression. Let me go ahead and label this. This is the force in member BC. Okay. How do I know it's in compression? Because when I look at this from a vertical perspective, I've got 6 kips pulling up, right? Because that was in tension. So this FEBC must be in compression to counteract that, okay? Again, this was a guess. It could be right, it could be wrong. We won't know until we actually get to the equation, okay? So, as I mentioned, I've got point joint B. I've got my known force of 16 kips from the reaction. I have the force from AB. I have the force BD that I'll be solving for, and I have a force BC that I'll be solving for. And let's just roll with that. Let's go ahead and solve the equations. Okay, so I'm going to start with some of the forces in the y direction. Now, one thing I should include on this before I forget is, let me put down the slope information. So we see we have a run of 4 and a drop of 3. So this is a 3, 4, 5 triangle, which is very convenient. Okay. Now let's go and write the equation. I've got 6 kips going up. Okay. And then based on my BC going down, I'm going to have 3/5 of BC. Okay, going down. Again, it's 3/5. Alright, going down, and that's all I have vertically. Okay, when I solve for BC, I see that BC is going to be 6 divided by 0.6, should be 10 kips, okay, and it is going to be in compression. The direction I assumed was correct, and I'm just using C for compression, okay? Now I'm going to solve forces in the y. I'm sorry, in the x direction. Okay. In the x direction, I have 16 going to the right. Okay. Didn't mean to mark that there. I've got my F. Let's see, my FBC, which I just solved for. I have 4/5 of that. Now that's going to the left, right? And again, FBC is 10 kips, but the horizontal portion of that is 4/5 of that. So I've got 16 minus 4/5 of 10, okay, minus FBD, because that's also going to the left. All that has to equal to 0. So again, the beauty of this method is there's no moments to take or anything like that. It's all just summing forces in the x and y. So here I'm going to have 16, 4/10 of 8 is 8, so 16 minus 8, okay, gives us a positive 8. You move that over, I see that FBD is going to be 8 kips, and that would be, let me just check, that would be in, let's see, compression. I'm sorry, the way I have it shown is compression. Okay. Meaning, here I showed it in compression, and I was correct. Okay. So that gives me the known forces in this member and this member. Okay. Let's go on to the next joint. How about joint D? So again, I'm going to do the exact same process. I'm going to draw in I'm going to draw a free body diagram of the joint. Okay. See, BD is what we just solved for. We found that it was 8 kips in compression. Actually, I'm just going to write down the magnitude. I won't write the symbol for. So it's 8 kips in compression. Okay. We don't know DF, but we're going to solve for it, and I'm going to assume that the force DF is going to the left, meaning that it's also in compression, because when I look at this from a horizontal perspective, okay, I'm going to have something to the left, I'm going to have something resisting it to the right, and then I'm going to have some force here, CD. Okay. So let's go after the low-hanging fruit first. First of all, when we look at this from a Y perspective, okay, what do we see? Well, we see that the FCD has to be what we call a zero force member. Okay, there's no force in FCD, because if you look at this, there's in our equations, equilibrium in the Y direction, there's nothing for us that balances it out. So FCD has to be equal to 0. Okay. Likewise, when we solve this in the X direction, okay, I've got a positive 8 kips going to the right, minus my force DF going to the left. So F, the force in DF, is going to be 8 kips compression. Okay, so now I know this one and I know this one. Okay, so now we have to continue on with this process where we go joint by joint. So I think my next joint I'm going to go after, I'll go ahead and just start with joint F. So now we're going to start, having worked our way through joints A, B, D, now we're going to look at joint F. And if I sound like a tape recording, it's because the approach that I'm going to use here is the same approach that we've used over and over for each joint. I'm going to draw the forces on that joint and write the equilibrium equations. Okay, so this is joint F. And from earlier, we see that DF was, okay, this force in DF right here, we solved in for the last joint, and that was 8 kips, and you can see it's in compression. This force here, I know it's going to go upward. This is going to be the force in member CF. The reason why I know it's going to go up is because, again, if I'm looking at joint F from a horizontal perspective, all I can see is I have 8 kips going to the right horizontally, so I've got to have some type of resistance going to the left, or counter force if you want to call it that. So I have force CF going off to the left. And again, I'm going to note its slope here. As was provided, it has a run of 4. A rise of 3, which makes it a 3, 4, 5 triangle. All right. Now, if FCF is going up, I can see that my force in member EF has to be going down. Okay. So again, I'm looking at joint F here. I've got a force EF here. I've got CF, and I've got DF. DF we had just solved for earlier as having 8 kips. Okay, and now I'm going to just apply equilibrium. Let's go ahead and start with forces in the X direction. Go after the easy things first, low-hanging fruit. I've got a force of 8 kips going to the right, which is positive. Okay, and that's countered by the horizontal component, which is 4/5 of force CF. That has to be 0. Let's see if I'm doing a CF. Okay. So when I take 8 and divide it by 0.8, I'm going to get a force of 10 kips. Okay, and this is and it's as I expected. It's in tension. It's going up. It's pulling on that joint. Okay, so there's CF right there. Let's go ahead and solve for EF now. Now that I know CF, we can go ahead and apply an equation in the vertical direction. Okay, CF has a component of 3/5, the force that we just solved for, which is 10. That's going up, minus FCF, going down, of course, is 0. Right, so 60% of 10 is 6. So FEF is equal to 6 kips. And it's in compression, as we've shown earlier. Okay. EF are there in compression. Okay. And so the only other force I have left to solve for is CE. And I'm going to do that by looking at joint E. And again, we'll just apply the same technique over and over. Okay. That is the method. So here we had an external force of 6 that we have to include, kips, going down. We also have another external force here of 6 kips going to the left. Okay. We just solved for EF, and that's in compression. And that was 6 kips. So vertically, I'm pleased, right? I can see that I have 6 kips going down at this joint. I've got 6 kips going up at this joint. And then the only unknown force that we have here is the force in member CE. Okay. Again, if I have a force going of 6 kips going to the left, this has to be going to the right, so we can see it's in compression. I'll go ahead and write out the equation, but you can look at it by inspection and solve for it. But I'll just go ahead and write out the equation. So FCE, which is positive, minus 6K is equal to 0. So FCE is 6 kips, and that would be in compression as we expected. All right. So if you look at the problem so far, we've actually solved all 9 members without ever looking at joint C. Now, if you have time, if you're not in a test situation, for example, and you have time, it is a good idea to look at joint C to see if everything balances out. So I'll go ahead and just take a minute and do that. Nothing else, just to make sure that my math throughout this video was correct. I've got a lot going on at joint C, as you can see. So I'll draw everything out. So there's literally 4 forces that converge at that joint, which was nice that I could solve this problem without actually having to do that. Okay, CE we found out is 6 kips, and that was CE is 6 kips in compression. Okay, let's see, AC is going to be 10 kips in tension. Right, that's what I solved earlier. AC. Oops, sorry, I have that showing in the wrong direction. Oh, that's right, that's right. Actually, what I'll do, maybe just a little cleaner, I'll just. Okay, so I have 10 kips going this way. Okay. BC we found was 10 kips in compression. And again, that's a 4, 3, 5. And let's see, CF was 10 kips in tension. Okay, so 10 kips make sure 4, 3, and 5. Let me just make sure I didn't miss any of these things. So I have to look back at what I did earlier. AC is 10 kips tension. CE was what we just solved. That's in compression. Okay. BC was 10 kips in compression. Okay. And this last member CF was right there, 10 kips in tension. Okay, so I have it drawn right. So hopefully when we look at these numbers, they work out. Let's see what I've got. In the x direction, I've got minus 10 here. I've got 4/5 of 10. There. Okay. I've got 4/5 of 10 here. Alright. And then I have minus 6 this way. So I've got 10 minus, let's see, that would be 4 minus 8. Let's see, a minus 10. 6. It looks like I've got that balanced out. And then let me look in the y. In the y, I've got 3/5 of 10 going up. And I've got 3/5 of 10 going down. Okay, so that checks. Let me make sure on this one. I'm not so sure on this one. I've got 16. Oh, that's right. Okay, so here you have a minus 16, and then you have plus 8, so that's equal to 0 as well. Okay, so that checks out. I was getting real nervous if it didn't work out. I had to record this video. Anyway, this concludes my example with the method of joints for a truss with 9 members.